I'm Ava Kerner, the founder and executive director of the API Project, a student-led organization dedicated to providing free, socially minded, intersectional health education resources. Today on the podcast, we're talking about exercise. If you're listening to this podcast, I'd recommend following along on the slideshow that we have on our website, which is just theappyproject.com. What is exercise? Exercise is planned, repetitive activity performed for the purpose of conditioning the body. And this is different from regular physical activity, which is just any movement done throughout the course of a normal day. Physical activity can happen when you're walking to the bus stop, you're rolling around in your sleep, cooking, whatever. But exercise and physical activity are different just because exercise is more for the purpose of increasing your physical fitness so you have more ease when you're doing physical activity. So exercise obviously affects our body. So we're going to run through a couple of the systems that it affects most, So the cardiovascular system is the system that pumps blood all around your body, and it includes your heart, arteries, your veins, and some would include the lungs if we're kind of combining the cardiovascular and the circulatory system, which we kind of are today. First up is the heart. It's a muscular organ located right in the middle of your chest, a little off to the left, you know where it is. And its job is to circulate blood throughout the body. So tissues need oxygen, and your blood is the kind of delivery device for that oxygen. So the heart will pump oxygenated blood out throughout your body, and when it encounters deoxygenated blood, which comes back up through your veins, it pumps it to the lungs where it becomes oxygenated and then pumps it back throughout the body. So it keeps that circulation going. And your arteries are little tubes. They're flexible, pretty elastic, and they're found throughout the body, and they carry oxygenated blood throughout the body to the tissues. Veins are their counterpart. They are less flexible, but, a little flexible. Tubes, again, and they carry deoxygenated blood back to the heart for reoxygenation. Next up is the muscular system. I think this has the most obvious connection to exercise because you use your muscles to exercise. And the musculoskeletal system is the system of your body responsible for locomotion, so moving around. Your bones are rigid organs. Yes, they are organs. Sounds a little weird. They are responsible for providing structure. That's pretty easy to see how. Cartilage is a type of connective tissue made up from the proteins elastin and collagen, and the ratios of these two proteins determine how flexible your cartilage is. Like the cartilage in the middle of your nose has more collagen than elastin, so it's pretty stiff in there. But say the connective tissue in your ear has more elastin than collagen, so it's pretty flexible. Your tendons are tissues that connect muscle to bone. They're usually pretty tough, but they can still move around. Your Achilles tendon is a tendon that attaches I'm pretty sure it attaches your heel to your calf. I'm not sure what the exact muscle and bone is. And then your ligaments are tissues that connect bone to bone. So you might have heard of your ACL. That's a ligament. Your MCL, even your PCL. Those are all in your knee. So those are pretty famous ligaments. And joints are where the magic really happens. They are places where bones come together. You have a bunch of different kinds of joints that allow for all different kinds of movement and different degrees of movement. So a synovial joint is the most mobile of the types of joints, and it is characterized by having kind of a bubble of lubricating fluid around it, and that fluid is synovial fluid. So you can see where it gets the name. Cartilaginous joints are a little bit mobile, pretty mobile actually, where bones are connected to each other by stiff, less flexible cartilage. Fibrous joints are the least mobile of your joints, and they are where bones are connected to each other by very stiff, very inflexible cartilage. And you have joints like this in your skull and in your pelvis. And there are a lot of different shapes of joints as well. Condyloid, ball and socket, plane, pivotal, saddle, and hinge joints. And all of those kind of allow for different types of movement, like rotational movement, hinge type movement, really all kinds of movement, any kind you can think of. Here is the real kicker, the muscles. Muscles are tissue in your body made of proteins actin and myosin, and they are responsible for locomotion through coordinated extension and contraction. There's a couple different kinds of muscle because the body just can't be simple. Smooth muscle is the muscle tissue that lines your internal organs. And what this kind of muscle does is, think of your digestive system. It kind of pulsates almost to push food or push stuff around. And that motion is called peristalsis. Cardiac muscle is specialized muscle, very specialized actually, and it's only found in the heart. And it has a lot of mitochondria, which are the little organelles that do cellular respiration, and they make the energy. You've probably heard that the mitochondria is the powerhouse of the cell. Well, cardiac muscle has a lot of these little guys because cardiac muscle can't stop pumping. If it stopped, you'd be dead. So it needs to be working constantly, and it really only does one kind of motion. It pumps your heart. That's it. One job. Skeletal muscle is the most prevalent kind throughout your body, I'm pretty sure. And it is muscle that controls the movement of the skeleton. So it's the muscle you're thinking about. And there's a couple of types of skeletal muscle. Type 1 is a kind with a high mitochondria density, which allows them to use oxygen for energy really efficiently. And these are called slow twitch muscle fibers because they take a little bit longer to react because they need to make that energy. And they are recruited in endurance activities, like if you're doing a wall sit or running a long time, because they efficiently use oxygen. Type 2A muscles have fewer mitochondria, and they use oxygen less for energy. And these are kind of your middlemen. Well, not middlemen. They're the in-between guys. And they're between slow and fast twitch. And they're recruited when necessary. Type 2B muscles are muscles that have very few mitochondria, so they don't really use oxygen for energy. They use a different process than cellular respiration called anaerobic respiration. And they generate lactic acid as a byproduct of this chemical reaction, and that kind of creates the burning sensation that you feel. And these are your fast twitch muscles. They are recruited in strength and power activity. Next up is the nervous system. So it might be a little less obvious how your brain is connected to exercise, but we'll talk about it. So the brain kind of acts as the command center of the body. It processes signals and coordinates response to the stimuli that it gets, like if you touch a hot stove. Well, actually, no, that's a bad example because that's a reflex. If you need to get something off of your desk, your eyes will see it, and it'll send a message to your brain, and your brain will process the message and send a message to your muscles, and you'll pick it up. And your neurons are kind of what allows that to happen. They're the specialized cell in your nervous system that transmits electrochemical messages to and from the brain through action potentials. Bundles of neurons are called nerves. And I might do like a science basics episode on what an action potential is, because that's a lot to go through in one podcast with everything else. But just know, an action potential is what happens in your muscles and in your nervous system to make something happen. And it uses electricity and chemicals. Your spinal cord is a chain of nerves running down the backside of your body, and that's where all the nerves branch off of. A neurotransmitter is a chemical released from one neuron and detected by another to elicit a certain response. And different neurotransmitters elicit different responses. And that's important in communication within your body. The endocrine system is the system that is responsible for your hormones regulation. So a gland is a specialized tissue that creates a substance. You have sweat glands, oil glands, and of course, hormonal glands. And hormones are chemical messengers that control different aspects of your day-to-day life, your life in general, like fertility, mood, metabolism, growth, and a lot of other things. The pituitary gland is a very important gland, and it's the main gland that's responsible for maintaining homeostasis of other hormones. So what the glands secreted by the pituitary gland do is they go to other glands and they tell those other glands what to make and when to stop making them, etc. And your hypothalamus is the part of your brain that controls the whole endocrine system. Cortisol is one hormone that we're going to talk about today. And it's the hormone responsible for your body's physiological response to stress. So, some benefits of exercise: improvement in the circulatory system, because when you exercise, your body has to efficiently use oxygen to keep all your tissues well and good, so that kind of improved effectiveness and efficiency carries on throughout your day-to-day life. Improved joint mobility and stability, because activity strengthens neuromuscular pathways, allowing muscles to contract more effectively with less preparation. Like, if you do something once, it's easier to do it again. And also, just having stronger muscles allows your joints to be more stable, which is always good, because if you fall, you'll be able to catch yourself, that kind of thing. And stronger bones are also a benefit of exercise, because the impact from landing from a jump or running breaks them down a little bit, and then they rebuild a little bit stronger. Benefit, which is, well, it's not the last benefit, it's just the last one we're talking about today, and it's probably the most attractive to most people, is the mood boost you get from exercise. So exercise increases the levels of serotonin in your brain. It gives you a better way to control stress via a cortisol feedback loop, and it increases endocannabinoid receptor interactions. So let's talk about the cortisol feedback loop. When you're stressed, like if you see, I don't know, something crazy happen, like a car crash or something like that, or just like a dog barking at you, someone yells at you, your hypothalamus will perceive that as a threat, and through a bunch of hormonal and nerve interactions, it'll trigger your kidneys, or no, not your kidneys, but your adrenal glands, which are on top of your kidneys, to release cortisol. And as we said before, cortisol is the main hormone responsible for stress. So now that there's a bunch of cortisol in your bloodstream, you'll have higher levels of blood sugar, because in a fight or flight response, you'd need that blood sugar to get you some energy to run away or something like that. You'll have increased respiration, all of the kind of things you associate with stress. But when there's a lot of cortisol in your bloodstream, it'll reach your pituitary gland, and your pituitary gland will downregulate the amount of cortisol that you're releasing. And that'll reduce your stress. And those effects can last for a couple minutes, a couple hours, or even a whole day. Exercise releases cortisol because your muscles are under stress. You are running far. You're doing these stressful activities for your body, which will release cortisol. And then that same interaction will happen where it reaches your pituitary gland, and the pituitary gland downregulates it. So that's kind of why you feel that end of exercise calm. Another reason you feel calm after you exercise is the interactions within the endocannabinoid system. And this system is responsible for feel-good chemicals. I mean, the name says cannabinoid in it, and those cannabinoid neurotransmitters make you feel good, like cannabis. You get the connection. So when you exercise, you release these cannabinoid chemicals, which then interact with the endocannabinoid receptors to make you feel good. There's a couple different kinds of exercise. Well, there's a lot of different kinds of exercise, but there's a couple different categories. So we're going to talk about two of them today, which are the two main ones, and pretty much everything else falls under them. Cardiovascular exercise is movement focused on raising the heart rate. So that's like running, swimming, biking, hiking, or jumping rope. Cardiovascular exercise has positive effects on the circulatory system because when you work out, your muscles need more oxygen and create more cellular energy, ATP. As a byproduct of cellular respiration, which is the process that your muscles do to turn glucose into energy, carbon dioxide